Hey, everybody, welcome back. You had a good weekend?
Yeah.
I did too. I was very entertained by someone that was. I assume in this class, well, at least the next class, but maybe not in it anymore. My professors had something pop up, they're like, you have a new thing on my email, so I went and looked. And someone in this class gave me a 1 for inappropriate video. Now, the only video I had played on Tuesday was the count. Which meant someone got offended by the count, which cracks me up because the count doesn't cuss. There's no cussing in that thing. Anything inappropriate in that video is stemming from your own brain. It's hilarious. I got a good laugh out of it.
I literally haven't even been on.
Alright, so. Previously, we had been doing some factoring, which is. Taking bigger numbers and breaking up. Taking large numbers. And busting them down into what makes them. Whoa. Zoom getting a bad beat. Hopefully it clears up. Into what's making them. And I mean through multiplication here. Let me try changing the settings on this real quick for you. Let's do stop share. And then I'll go back to sharing the other one. Hopefully that fixes it. Nope, it doesn't. Hopefully the camera clears up. Cause it's fine in class. It's a Zoom thing right now. So like. We talked about things that multiply, remember like. If it was a multiple of 2, it ended in. 0, 2, 4, 6, or 8. If it was a multiple of 5, it ended in. 0 or 5. And if it was a multiple of 0, it ended in 0. Or multiple of 10, it ended at 0. The 3 was an interesting one, the digits added to something divisible by 3. And we had said all that there, oh good, it cleared up. It's better. So if I wanted to factor 750. This is clearly divisible by 2. I'll show you 2 ways of going about doing this. If you're going like smallest number to largest number. 750 divided by 2. Is 375. So this is 2 and 375. And then this no longer ends in an even number, so no more 2s. 3 plus 7 is 10, plus 5 is 15. 15 is divisible by 3. So 375 is divisible by 3. So if I divide that by 3, I have 3 and 125. These are prime numbers, so I'll circle them so they know they don't break down further. 125 is not divisible by 3, so we'll try, I can see it ends in a 5, so it's divisible by 5. And that gives me 25. And hopefully 25 you recognize as 5 times 5 from the multiplication table. So 750 is 2 times 3 times 5 times 5 times 5. This is the same thing as writing 2 times 3 times 5 cubed. This is called an exponent. Am I screen? Thank you. It's called an exponent. That's called the base. And the exponent says how many times the base should multiply by itself by. Now, this isn't the way I would do it, I wouldn't go in this order. Simply because I tend to recognize things that are powers of, or multiples of 10 and deal with it that way. So another approach to 750. Is recognizing that is 75 times 10. And hopefully 75 is a number you know simply from money. That is 3/4. So 3 times 25. 25 is 5 times 5. And 10 is 2 times 5. We still have our 2. Still have our 3. And we still have 3 5s. So there's not always just one exact process to factor them, but the result should get you the same. Pause, let you finish on that. I think there's any tweaking in that. It tastes like tea. It just like it's a problem. But it's wet. And I'm gonna be talking for 3 hours. Doesn't get complain too much, it was free, I could start on it, so. You guys ready for more? Nope, a couple people are still writing. We giggled over that that review, said I was unprofessional, I only talked about myself, I was completely unprepared. I'm like, bitch, please, there was a 40-slide show about myself. How much more prepared do I gotta be to talk about myself than have a slideshow that big? You can bitch about me talking about myself, a lot of students don't really like care for it, but. In the end of the day, everyone knows who I am, knows about me and knows something they have in common with, I am more approachable. Alright, you guys ready?
Yeah.
Excellent, cause the pain continues. Did I say pain? I meant fun. Let's do LCD. I was about to say something else, which is completely wrong. Least common denominator. Or maybe the lowest, I never remember anymore. Maybe I should look it up and see which one it is.
It's least.
It is least, right? Least sounded right, but like lowest sounded right too. But if you don't know what least means, hopefully you know what lowest means. This is the smallest. Denominator or bottom. We can have. When we start. With two or more. Unlike fractions. So that. They end up. Having the same denominator. Or bottom. You'll be Marcus.
Come on, my cat, yeah. I'm sorry.
Is it good? Like the bookstore?
Yeah.
Good, I haven't had it yet. They gave me a voucher for a free coffee. I was like, score, okay. I know I tried one over at the grind during the summer, and I like. You guys actually did a pretty good job. They gave me a student discount, which I really liked, cause I don't look anything like student. Maybe they just gave it to everyone, like half price coffees. Y'all got a lot nice over on the Visalia campus. That cafeteria used to be not so good food. I've had their food lately, like by surprise, it was brought to a meeting. I was like, this is really good, where's it from? And they're like, it's from the cafeteria, I'm like, get the fuck out of here. They're like, it was a cafeteria, like they have a new cook, like person in charge, yeah.
Culinary students actually could.
Do they?
Yeah.
That makes sense, I don't know why they didn't do that all along.
My brother swears by their chicken sandwiches.
Yeah,
He's
that's
really
really
good.
good.
Yeah,
Nice.
my brother is at the Visalia campus right now. He always bring one up.
Yeah, when I was a student here, it wasn't bad, but like, we had like a Carl's Jr. in there for like the back part of the room. And there was no like student discount or anything like that, you were paying full price. Alright, that's enough writing about that. So like an unlike denominator, or unlike fractions. I don't know if I said this before. Means they have different bottoms. Different denominators. And like fractions have the same denominators. So if I had something like. 7/80. Plus 3/40. Minus 9/20. I can't combine these until they have the same bottom. And preferably the least common denominator. You can always get a common denominator by just taking them and all multiplying them together. But as that is generally not the lowest, and then you get problems where you gotta simplify and a whole lot of other shit. Can you talk about simplifying fractions yet? I don't know that we did, we haven't done a whole lot yet. Oh, yeah, we did it. We did the pizza. The 3/12 down to 1/4 kind of thing. So one thing you check, if one is a lot bigger than the rest. Check to see if the biggest one divides evenly by the rest, if it does, you're good. So does 80 divide by 40? 80/40 is 2, so it does divide by it. Which means I can start with the 3/40. And I can end with an 80 on bottom. If I take this and I multiply the top and the bottom by it. Now, 2 divided by 2 is 1. So I'm technically multiplying by 1. Which is important. You don't multiply by one doesn't change the value of the number, that's important, we don't wanna change it. We're just trying to make it so we can combine. So here, when you multiply fractions, you multiply tops separately. And bottoms separately. So we end up with 6/80. I can check the 20 as well. And 80 does divide by 20. We get a 4. So I can start with the 9/20. And take that 4 and multiply both the top by it and the bottom by it. And I get 9 times 4 on top. 20 times 4 on bottom. This is 36/80. With that in mind, those new values, I can literally take this and rewrite this. As 7/80 plus 6/80. Which is the 3/40 just rewritten. And then minus the 36/80.
I'm kind of lost, where did the 80 divided by 20 come from?
I was checking, this is the biggest denominator I had, so I was checking to see if I could divide the other ones into it. Cause if you can, then that's the number you're going for. We'll do an example in a second where that's clearly not the case, so there's gotta be other strategies. I checked to see with the biggest one to see if the others evenly divide into it, it's the quickest. You'll see on the next problem we do that it's, there's a method that works just fine, but it's not as fast. When we add and subtract fractions. With the same bottom. The add subtract is only on top. And what? If I could be. Oh, refocus, okay. I hate when it powers off, because then it's like off for 45 seconds. What I mean by that is we will have just one denominator and it's gonna be that same 80. And we can do all this adding and subtracting up top. Now, this is an example you probably won't see in statistics because we're gonna end up with a negative number. And a lot of our probabilities in statistics are just between 0 and 1. A lot of our fractions. This ends up being, if we add 7 plus 6, it's 13. Minus 36 is negative 23. If you did it in a calculator, it's gonna tell you negative 23/80. Now, when you combine everything in a fraction, like if it shows up in the homework. They're going to expect you to simplify it too. So simplify if you can. That means like factoring the numbers and doing all that good stuff. 23 is a prime number though, and it doesn't divide into 80, so I know this doesn't simplify. But hope maybe the next one will. Are we ready for some more fun? Anyone still writing? Yeah. Are you sure?
Yeah.
So let's do something like, 9/14 minus 7/20. Plus. 11/70. Now here, 70 does not divide evenly by. 14 or 20. Jesus, that's bad handwriting. Put my arm at a crooked angle on it, so it looks like I'm in kindergarten already. So when it doesn't work like that, what we're gonna do is we're gonna. Factor all the bottoms. And with those, I'm gonna make a table. Where each row. Is one of the bottoms. And each column holds. One unique factor. That may sound weird, but I'll show you what I mean. I said, we're talking about. So you can put it when you're comfortable factoring, you can put it directly into the table. But I'm gonna start with 14. And 14 is 2 times 7. 20 is 5 times 4. And 4 is 2 times 2. And finally, 70 is 7 times 10. And 10 is 2 times 5. So I factored those numbers all into their prime numbers real quick. Alright, so for my table. I'll make a list of each denominator. 14, 20, and 70. Fourteen is 2 times 7. First row, you just write it as is. Now the 20 has 2 2s and a 5. I've got one column that's got a 2 in it, I'm gonna put the 2 in that column. It can only hold one 2, so I'm gonna make a new column for another 2. And I don't want it to be in the 7 because I want the 7 to be its own column. So it's like we're gonna make our own columns for each number here as we need them. And then 20 had a 5. And finally, 70 is 7 times 2 times 5. I've got a 7 there, I've got a 2 there. And I've already got a 5 here, so I don't need a new column. Does the structure make sense? May not understand why I'm doing it yet, but does the structure make sense? Each column has a unique number. We don't put like two twos in the same column. We don't mix them and put like a 2 and a 7 in the same column. And when we do this, the LCD is just one from each column. It equals 2 times 7 times 2 times 5. That is 14 times 10 or 140. And if you want to do this where each column is like that, we get the LCD and it actually, the gaps are used to figure out what to multiply by. So for example, my 9/14. It's missing a 2 and it's missing a 5. So it's missing 2 times 5 is 10. So if I multiply this by 10/10. I will get 140 on the bottom. And I will get 90 on top. What is the 20 missing? It's missing the 7, right? And then 11/70 is only missing the 2. So 90/140 minus 49/140 plus 22/140 is what the fraction now has, and now we can put them all together because they have the same denominator. Oh, what do we get? 41 plus 22 is 63. Now, if we're trying to simplify, this is kind of neat. Can we simplify? Well, 140 is really big and I don't want to factor that, but guess what? We don't have to, we already got the factors. So take those, put them in down here, don't like try to refactor it. You already know what multiplied to make it. Now we just gotta do the 63, what does 63 break down into? Anyone know? It's on the times table. 9 times 7. And 9 would be 3 and 3. So it looks like a 7's gonna cancel. And the top is 3 times 3. The bottom is 2 times 2 times 5. We end up having 9/20.
You look at for affection.
Was that off the screen?
Yeah, just a little bit.
You may have learned it another way, you probably did learn another way, I came up with this table thing in the shower. Like 5 years ago, and then like last year. A new textbook had it in it, I'm like, what, it was a textbook by someone here. And I don't know if they had it in there and I've just never seen it. Or if they heard me talking about it and added it to their textbook. But I really like the table. I had a student that just was not getting fractions and I multiple or factors and anything like that, and it took me, like, it just, I had an epiphany. Why don't I give you guys one to try? Wait, people still writing now. Slow your roll, Jones. You have a name tag on, why do you have a name tag on?
I'm a special education teacher.
That's gotta be fun. I've got a head rush. I can't imagine Berkeley giving me a head rush, but. You guys ready? Alright, now it's your turn. You try. If you wanna talk with your neighbors about it, you're free to do so. Do 9/14 minus 1/6. Without a calculator, trying to do this little table thing if you can. Like, don't, if you need a calculator along the way, use it, but like, try to do this as much as you can without a calculator, it builds your math skills. And we'll do it together in a couple minutes. And if you like the little table thing, I'll put it back up so you can see what it looked like. On the left. Like some paper markers? Very good. 6, 18, 22.
Please.
Nick, my other cheek. So we're trying to do it in his head.
I'm going to my notes up.
Now I feel guilty. I should have let you guys, because. That's a good skill to develop. No, put the calculator in, keep trying,
I'm on my notes now. I'm writing it down.
Okay. Y'all get an LCD? What'd you guys get?
Not 42.
42 is what I got. So if we do the 14. Back, we had 14 on our other page. Shit, I even had 9/14 on the other fucking page. I was picking numbers at random on, that I had on this page. And then I turned the page and had the same fucking fraction, isn't that a bitch? 14 was 2 times 7. 6 is 2 times 3. So our LCD is 1 from each column. And 2 times 21 or 6 times 7 is 42. So if you want to speed it up, not write a whole bunch of fractions, I can make the denominator 1 time. And I can fill in what's missing as we go. The 14 denominator is missing the 3. So I'm gonna write 9 times 3 here. And then we have a minus sign. And I had a 1. And the 6 was missing the 7. So that's times 7. Following that through, you'll have 27 minus 7 over 42. And you get 20 over 42. Did anyone go further? Good. You're supposed to go further. These are both even numbers. So. 42, we already saw is 2 times 7 times 3. 20 is 5 times 4, which is 5 times 2 times 2. And we can cancel a single 2 on top and bottom. We're left with 5 times 2 on top, 7 times 3 on bottom, or 10 over 21. If you got to the 10 or 21, good job. You guys just high five each other.
Yeah.
That's fucking awesome. I said you guys, it's 2 girls. Which is weird. You never hear you gals, that's not something that you hear. It's always like you guys or y'all.
Just say y'all.
I would say.
I'm a big fan of y'all.
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 Guys.
Got the, I don't do the southern drawl very well.
Hey, y'all. What up, y'all?
Alright, you guys want a harder one? Yeah, you do. Someone said yes. I see a nodding head, so guess what? Have fun.
No.
No one's making you do it. This is for your own benefit. Do 3. Southern drawl. Spiel until 100. Alfredo. Do you like chicken Alfredo?
My icebreaker. So.
I figured it was. Like every time I think about your name, it's like. Fuck, cause I see you from 3 to 6, like, well after lunch, but before dinner going. You know what, Alfredo sounds fucking pretty good for dinner. Which is fucking wrong, cause of the first time it pops in my head, it's from associating by looking at you. So that sounds just like cannibalism and shit. When I hear the words in my head. This does not sound appealing. I don't know that I will ever be hungry enough that I will eat human. Well, unless I go vampire. And then go all the fucking dinner.
I don't know if I can tell that story. I think our team's hungry.
That's a concise way of putting it. I make my teacher hungry. That sounds so creepy. And yet not what was intended. But I do shit like that all the time. I will rephrase the story to tell, make it factual, but like, sounds so fucked up. That's good shit right there. I know you're gonna tell people that. You're welcome. Give you good stories. I'm having spaghetti for dinner, so that's not quite the same, but it's still a pasta. Alright, so we do this together. 10 is 2 times 5. 35 is 5 times 7. 21 is 3 times 7. Oop. I need a new column for 3. Looks like the LCD is 2 times 5 times 7 times 3. 10 times 21 is 210. Woo. The 3 is missing these two. It's missing 7 times 3, which is 21. And I have a minus 6. And I'll write the 7 and the 3 above it. The 6 is missing a 2 and a 3. 2 times 3 is 6. And the 4 is missing a 2 and a 5. 2 times 5 is 10. So 21 times 3 is 63. 6 times 6 is 36. And 4 times 10 is 40. I'll be honest, I can't do 63 minus 36 easily in my head, but I can do 40 minus 36 pretty easily in my head. These two make a 4, so 63 plus 4 will be 67. And I believe 67 is a prime number, so we don't need to check.
Or
Oh, okay, so like normally you do the adding and subtracting left to right. But I'm not really any good like this. I can do this in my head, but I'm gonna second guess doing these two in my head. So what I did is I kind of like switched the order around and did this. And then I could do that in my head. 40 minus 36 is 4. I can do that pretty easily. When I have a number that ends in 10, I can do the subtraction pretty easily, but numbers that are different, I may struggle with. So like I switched the order around so that I could do it without like fucking it up. In fact, this switcheroo of these two, swapping places, is called the commutative property. The sign has to go with it. Sign has to swap with it. So that's what I was doing here.
Can you go over slowly, please, what we're supposed to do with the writers,
With the what?
the top color?
So, go through this, find the holes. Multiply whatever that denominator was missing by onto the top. So on the row with the 10, we were missing a 7 and a 3, so I took my 3 and I multiplied it by the missing pieces. This is the same thing as doing it separately, multiplying the top and bottom by 7 times 3, which I did was doing separately in the beginning. This will get us 210 on bottom. This gets us 63 on top. And then you can do that for each one. If you don't like doing it all at once, stuff like that, please don't. Do it the way you're comfortable with. 6 times 35 was missing the 2 times 3. So I'll multiply by 2 times 3. And the bottom should equal 210 each time, so I'm not so much worried about that. 2 times 3 is 6, 6 times 6 is 36. And then the 4/21 was missing the 2 and the 5. So I'll multiply by 2 and 5. That's 4 times 10 is 40. If you want to do those three separately, then line them up like this, please do. It takes more paper, but you can do it. If it's clear for you. I'm off screen. Did you forget something? Alright, I'll hit stop record. It did say gaps. Brittany, if you have a question, when you do it, like you can, if you can, turn on your mic and ask. I'll try to